Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome once again to all of you to the physics classes. Dear students, we were discussing about motion in a straight line, and in that most of the topics we have completed and we have concluded motion in a straight line chapter, and the problems also we have discussed. Okay, so go through the numerical sums which we have included in motion in a plane, okay, as well as go through the derivations, okay, which are very important. So what we have studied in the motion in a straight line? Motion in a straight line, simple thing we have studied that object which are moving in one direction, maybe it is left to the initial point, or maybe it is right to the initial point, or else it is positive direction or a negative direction. Okay, so means motion in a straight line in single dimension, in one dimension we are going to talk about, because in a frame of reference what we have studied, so motion of the object will be in 3 dimension. No, you are not only walking in x direction, you are not only walking in negative x direction. So what happens if suppose you are moving upstairs in this way, no, so you are moving x axis, no, in this way. Now if you go means z, x, y, z axis also you are moving, no. So say for example like these stairs are there, now you will go here, you will come here and you will move here, no, x axis also you are moving, z axis also moving, y axis also, that becomes 3 dimensional. If you are moving only in this way and moving up and up, that will be only x and y axis or x and z axis, okay, like that. So motion in one dimension, what we have discussed, only in one dimension, maybe only in x axis, maybe only in y axis, maybe only in z axis. So only x axis means it is positive x, negative x. Only z axis means it is positive z, negative z. Only y axis means it is positive y, negative y, in that way. Okay. So now we have studied most of the things. No, it seems that we have studied for motion in a straight line, everything we have studied. We can define motion in any way. We have got 3 kinematic equations. So everything we can define, everything we know. Is it like that? If I ask the question, motion in a straight line we have studied, lot of equations we have studied, lot of physical quantity. Physical quantity means that is measurable, some quantity in physics, that is physical quantity. Okay, everything is physical quantity. See, if I say time, if I say velocity, if I say momentum, if I say temperature, if I say speed, if I say path length, if I say displacement, if I say acceleration, okay, if I say instantaneous velocity, whatever with the quantities we have studied, those are called physical quantities. Okay, those are called physical quantities. Now the thing is, those physical quantities we know, and what we have to do is, we have studied only one dimension. No, whatever physical quantities we know, we can't use it for 2-dimensional motion. Okay, because there only x axis was varying, but here it is not like that. No, x and y, it is moving in this way, y axis also it is moving, right, y axis also it is moving. Okay, so what to do now? Shall we use all the mathematical steps and all the quantities which we have studied in our first chapter? Is it possible? Is it possible? No, it is not possible. For that, we will bring a new term, new mathematics, new kind of equations, new kind of mathematical interpretation or mathematic things, that is called nothing but vectors. So before we will move into the motion in a plane, that we will call we are going to discuss vectors. Now what do you mean by motion in a plane? Motion in a straight line means only x axis or y axis or z axis, isn't it? Z plus z minus z. Y axis means is towards you. Okay, I can't write down in the board. No, it is towards you. But motion in a plane means if I write down x and y and z. I will write down this as z. Okay. So this is xy plane. So this is which is that plane? xz plane. So this is zy plane. Now if you assume this classroom and any one of the corner of the classroom or room, there is edge, no? So one axis will be in this way, one axis will be in another way, one axis will exactly at the corner of the room. If you consider, I mean, see, this is a room, a box, isn't it? Okay. So in this way, if you see any one of the corner, you will see x, you will see y, you will see z at the corner. And now what happens? This we are actually working on x. If you name it as z, if you name it as x, if you name it as y, means we are actually moving in x and y axis. X and y. Only we are moving in straight line. No, we will move in this way, somewhere this way. No, in a room. So the floor will be x and y plane. Okay. Any of the wall which you have considered, this corner if you consider, means this becomes, see, if you consider x, y and z, means this plane becomes yz plane, this plane becomes x and z plane. No, this is vertical plane. No, so that's why this plane this is called plane, means two axes are involved in that, xy, yz or zx, xy, yz or zx, that is a plane. Okay. So motion in a plane, a mathematical word, okay, plane, motion in a plane, not any other things. So that is nothing but motion in a plane. So to understand that, or motion in two dimension we will call it is. That was motion in one dimension, motion in a straight line is in the motion in one dimension. Now this is we will call motion in two dimension. What is two dimension? X and y, y and z, or z and x, like that. Okay. For that we need vectors. Now simple case, when we were talking about mathematical tools of physics, we have discussed, no? So I am going to write down in this way, and x, y is there, no? In this way some force we have discussed, no? So here what we will have is a term called vector we have. Vector is nothing but which represent vectors and scalars you have to study. First two quantities we are going to study, that is nothing but scalars and vectors. What do you mean by vector? Now I will write down time. See, you make two boxes. One box is this, one box is this. I have lot of physical quantities. I have time, I have velocity, I have path length, I have displacement, acceleration, temperature. Okay, then temperature, then which are all? We have temperature. Any other physical quantities? Yes, pressure, volume, length, breadth, which are measurable, all are physical quantities. Okay. Now whatever we have studied, acceleration, time, displacement, speed, all those we have studied, no? If any physical quantity you write down, say for example I will tell time 3. What is 3? Seconds, hours or minutes? No, we are going to write down, no. So what is this actually? After writing this number, we are writing some value, no. This is nothing but unit. 3 minutes is a unit measurement. So how you will calculate from this point to this point? You will take a scale and you will measure it. You will write down it is 12. What it is 12? Centimeter is a unit of length. Second is the unit of time. Kg is the unit of weight. No, there is some measurement. All quantity you are measuring, you have to write down in this way. No, then only it is valid. If you just write down 12, what 12? It's a number. This gives some meaning. 12 centimeter means 12 kilometer means exactly, no, you will understand that it is length itself. 12 kilometer you won't say, no, it is time. Time is 12 kilometer. No, time is 12 seconds. Means The meaning is gets any number with respect to if you write down a unit in physics. Okay. Now what we were discussing, I'll ask you to make two boxes and I will give you physical quantities. And you have to put which is scalar, you have to put in this box, which is vector, you have to put in this box. Number of physical quantities are given. Now on what basis you have to put? The scalar quantities are those which are having only magnitude. Magnitude means it's just number. Time is a magnitude. What is the direction of time? What is the direction of time? Positive direction, negative direction, upward direction, downward direction, left side, right side, like that it is there. No, time is a quantity. So time will be a scalar. So the quantities which are having only magnitude are called scalar. So you have to write down physical quantities having only magnitude are called scalars. Okay, then what do you mean by vector? If I ask velocity, velocity means it is a magnitude. 3 meter per second, it is also direction is also there. 3 meter per second in which direction? In positive direction it is moving, or negative direction means that physical quantity is having direction. So it is a vector quantity. Means what? Vector quantities are those physical quantities which are having both magnitude and direction. Scalar quantities are those quantities which are having only magnitude. Vector quantities are those physical quantities which are having both magnitude and direction. You have to write down. Vector quantities are the physical quantities which are having both magnitude and direction. So velocity we have to put in this box. Next, path length direction is there? No, right? Path length means it's the total value. You go anywhere in this direction or this direction. Path length was what it was? It was just a number. So length, path length means we will just write down length is a scalar quantity. Then displacement is a vector quantity because it is having direction. Then acceleration is a vector quantity. Temperature is a scalar quantity which is having only. Okay. Pressure is usually a, okay, we will consider a scalar. Actually it is sometimes behaves as if like a scalar, sometimes behaves as if like a vector. That is based on our need we are doing. Okay. So that we will study in the later classes. Volume, what is the direction of volume? Direction is there? No, it is not having direction. So volume is nothing but volume is a scalar quantity. Then length is a scalar quantity. Breadth is a scalar quantity. Then vector quantities are only this much? No. Force is a vector quantity. Then any other vector quantities are there? Velocity, displacement, force, acceleration. We will have momentum. We don't know about this, right? We will going to understand, learn in our next videos, okay? That is momentum and all, okay? But as of now, you should know there is scalars and vectors. Now, what are the differences between scalars and vectors? So, scalars are nothing but the quantities which are having only magnitude. Vectors are the quantities which are having both magnitude and direction. Those are nothing but scalars and vectors. So, first you have to write down differences. Okay, differences means physical quantities having both magnitude, direction. No? Okay. So there is a concept called representation of vector. There is a concept called representation vector, as we have represented in graph, right? Other things. Similarly, we are going to represent the vector. Okay. So that we are going to represent it by using a line. So now what I will do, this is north, this is south, this is east, this is west. You are somewhere here. Now what I will write down, you are moving in the east direction, means I will write down in this way, one line, okay, and I will write down V, which is equal to 3 meter per second. I will write down. So what is the meaning of that? This is a vector. Vector means you are going to write down after a letter, on that arrow mark you are going to put. Generally you can also write down a arrow, arrow, a line with the arrow. Arrow indicates the direction, and this is called tail, this is called head, this indicates the direction, and total length indicates magnitude. Magnitude means it is less, or magnitude means some number. If 3 meter per second means I will write down in this way. 4 meter per second means I will write down this way. 5 meter per second means I will write down in this way. 7 meter per second means I will write down in this way. Means a little bigger line. Simple, just a graph, okay. This is just a graph. What I mean by vector representation? Graphical representation. We will call it is graphical representation. Graphical representation of vector, that is nothing but graphically we are going to write down, okay. So what is going to write down graphically? Graphically is nothing but a arrow headed line you are going to write down, okay. That point we will call it as a tail, head, arrow we are going to, arrowhead we are going to call it as head of the vector, and then arrow indicates the direction, length indicates the magnitude, okay. Any direction you have to write down. If say for example a butterfly is there here, okay, so in a plane it is moving, no, it's just crawling like this. It was initially here, it will go somewhere here, in this way, 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 and now the butterfly is here, okay, butterfly is here. Now what is the direction of motion? Direction of motion is in this way. The displacement vector I am going to write down from initial point to final point. We are not going to write down butterfly diagram, we are going to write down just a arrow mark from initial to final. This is the displacement vector. So I can represent it in this way. So what is the displacement? Say for example 5 meters. 5 meters is the displacement. In which direction? In the direction of arrow it is, like that. That is just a representation, we can write down graphically, okay. Now what we studied, to understand the motion of the object in a motion in a plane, what we want a special type of quantities, that is called vectors. Then another quantity is there, that is called scalar. Scalars are the quantity which is having only magnitude, and vectors are the quantity which are having both magnitude and direction. But scalars are nothing but just a number. Scalars are nothing but just a number. But vectors are not a number, these are having direction also, okay. If temperature means I will give just a number, it is having no direction, it is just a number, okay. But vector means velocity, the vector means it is meter per second, it is having some direction, okay. All the listen properly, all the mathematical rules of scalars we can't use for the vector. Vector have its own mathematics, a different mathematics, that is called vector mathematics, okay. So vectors are the quantities which are having both magnitude and direction, as well as which will obey law of vector addition and obey law of vector addition. What are those laws that we are going to study, okay. So what is the next difference? So if I write down the vector in this way, here O A, this is A vector, in this way I am going to write down. Now the same vector I will shift to here and I will write down in this way. Whether vector is changed, whether direction is changed, there is no changes in this vector. So these vectors are same. But if I write down a smaller length like this, the same vector if I write down like this, direction is same, but is it magnitude is same? No, means this is no longer a vector, this is some different vector. Okay, so if I change the magnitude means length. Okay, here magnitude indicated by the length of the vector. So length means length we will change means magnitude is changed. So if I write down in this way, length will be same. If I write down in this way, whether vector is going to change? Yes, because this is not the same vector, the direction is different, direction is different. So okay, if magnitude changes means scalar changes. Okay, scalar can be changed, scalar quantities, okay, they changes if their magnitude is changes if their magnitude is changes if their magnitude is changes. Okay, this one means vector has to change means one thing it has to change its direction, another thing it has to change its magnitude, or both. Okay, so whatever any one of them also changes, also it is going to changes. Vector changes if their magnitude and direction or both changes. Vector changes if it changes its magnitude, okay, comma, direction or both. Okay, one thing magnitude has to change or direction has to change or else both has to change. That is another difference. So next what you have to write down? You have to write down the example for scalars. What are the examples for scalar? Mass, time, volume. Okay, what are the examples for scalar vectors? Velocity, displacement. You have to write down velocity. Okay, displacement, acceleration, all those things you have to write down. Okay, so this is nothing but differences between vector and scalar. So what we have studied? We have studied to study motion of the object in a plane, we want a new type of mathematics, that is called new type of quantities, that is called scalars and vectors. Vectors are having its own magnitude and direction, but scalars are having only magnitude. Scalars are having only magnitude. Okay, and the differences we have studied. Okay.
Don't forget to like our video and subscribe our YouTube channel for all the updates.